Hello viewers, you are welcome. In this video lecture, we are going to look at trigonometric identities. Of course, the lecture is Math 103 and it is trigonometry and coordinate geometry. So the trigonometric identities we are going to look at, we are starting with Pythagorean identity. Suppose this is a right angle triangle. We have, so here is y, here is r, and then here is x, and theta is the angle here. So it is clear that by Pythagoras theorem, it is clear that from trigonometric ratios that sine theta is equal to opposite over hypotenuse, which is y over r, and then cos theta is equals to adjacent over hypotenuse, that is x over r. So call this equation 1. But we know by Pythagoras theorem, it is well known that r squared, or we know it is clear that x squared plus y squared is equal to r squared. That is, the square of the hypotenuse is equal to the sum of the squares of the other two sides. That is the opposite and the adjacent sides. So, dividing this Pythagorean equation by r. So what do we have? By r squared. So we have x squared over r squared plus y squared over r squared equals to r squared over r squared. That is call this 2. So 2, equation 2 divided by r squared, and so this is what you have. But this becomes, so this is x over r, this has squared, so all squared. According to law of indices, this is y over r, all squared, and this is r squared over r squared, but the answer is equal to 1. But what is y over r? So what is x over r? It is cos theta. So x over r is cos theta. I have cos theta, but with a square here, so I have cos square theta, plus what is y over r? From here, y over r is sine theta, so sine theta, with a square here, so I have sine square theta, and this is equal to 1. So I have this to be equation number 3. So what this equation is saying is that cos square theta plus sine square theta is equal to 1. So equation 3 is called the Pythagorean identity. Pythagorean identity. That is equation 3. It's referred to as the Pythagorean identity. Now, subtracting sine square theta from both sides of equation number 3 of the Pythagorean identity, that is equation number 3. So this equation number 3 is cos square theta plus sine square theta. So we are subtracting sine square theta from both sides. So this is minus sine square theta. This is equals to 1 minus sine square theta. Now, but sine square theta will go with sine square theta. So we have cos square theta is equal to 1 minus sine square theta. So call this equation number 4. Here is another identity. Again, subtracting cos square theta from both sides of equation number 3, the reference equation. So what we have here is you are saying cos square theta plus sine square theta minus cos square theta. This is equal to, so I have 1 minus cos square theta. So from the left hand side, what you have is cos square theta minus cos square theta. You are left with just sine square theta, so that you have sine square theta is equal to 1 minus cos square theta. And this is another interesting equation. You call it equation number 5. All right, now to obtain another identity, say, okay, now dividing equation number 3 by cos square theta. So you are dividing through by cos square theta. What are you dividing? Equation number 3. And equation number 3 is cos square theta plus sine square theta is equal to 1. So dividing here by cos square theta, dividing everything by cos square theta, dividing this by cos square theta. So if you are dividing by cos square theta, and this is what you have. So cos square theta by cos square theta, the answer is 1 plus sine square theta over cos square theta, the answer is tan square theta, and this is equals to 1 over cos square theta. And what is 1 over cosine? 1 over cos is sec, so this is sec square theta. And this is another equation, call it equation number 6. Now to obtain another identity, we say, okay, subtracting 1 from both sides of equation number 6. If you subtract 1 from both sides, this is 1 plus tan square theta minus 1. This is equals to sec square theta minus 1. So here I have 1, here I have 1. So 1 minus 1, the answer is 0. And so I have tan square theta is equals to sec square theta minus 1. Here is another important identity, and that is identity number 7. Similarly, we can obtain another identity. We can obtain another identity by dividing both sides of equation number 3 by sine square theta. And what is equation number 3? This is cos square theta plus sine square theta is equal to 1. So dividing here by sine square theta, dividing here by sine square theta, and dividing here by sine square theta. What do we have? So cos square theta over theta, cos over sine, cot. That is the reciprocal of tan. Remember that tan theta is equals to sine theta over cos theta. So now, if we have cos theta over sine theta, that means we have cot theta. That is the reciprocal of tan theta. Now plus sine square theta over sine square theta, the answer is equal to 1. 1 over sec square theta. The answer is cosec square theta. So cosec square theta. This is another identity, identity number 8. Also, subtracting 1, this number 1, from both sides of equation number 8. Equation number 8, we obtain, so if you subtract 1 here, you are going to have cot square theta plus 1 minus 1. Here will be cosec square theta minus 1 also. You have subtracted 1 from both sides of the equation. And so 1 minus 1 will go. You are left with cot square theta is equal to cosec square theta minus 1. Give it equation number 9. So these are some of the basic trigonometric identities we have. See you in the next example, in the next video for more examples. Thank you.